Jeez. All right, now you can hear me. That was annoying. So yeah, every time I start OBS, since I move my computer around, it switches to a different audio input. So now you can actually hear me. And hopefully you could at least hear that beautiful music before I came on and didn't talk. But anyway, if you can hear me, put in chat that you can hear me, and we'll see if that actually works. Okay, good. Anyway, today I'm going to try getting this GeForce GTX 1080 working on this Raspberry Pi Compute Module 4. If you don't know it, this is actually a full Raspberry Pi, but it's on a little board that doesn't have any input or outputs. Instead, it has these tiny little connectors. Focus. It's focusing on my face, I think. There we go. See those tiny little connectors? So you can connect this to any kind of board. For example, the I/O board over here, this guy, which is not showing at all. My camera just shut down. This is the fun thing about using a Raspberry Pi as your webcam. It actually can turn itself off by itself. So I'm going to unplug that and plug it back in, see if it comes back. But anyway, you can plug this into different boards, and the I/O board itself has a PCI Express slot on it. So you can plug in video cards and things like that, like this one. So that's what we're going to try to do today. I've actually tried 5 different video cards, including in the last video that I did, this little guy, which is an M.2 video card from ASRock Rack. So it's fun to see the size comparison of this little M2 card and this insanely chunky video card that I will pull out. Now, whoops, I just opened this upside down. I'm glad it didn't fall out on me, because this is worth more than all the Raspberry Pis I own because of the GPU shortage this year. This was sent to me by somebody in Texas, Eric, who is a friend and former coworker. He does do a lot of gaming, which I don't do a whole lot of gaming, but he actually had a 3090 in his hands. This was before the GPU shortage. He had a 3090 and then he sold it off or gave it to somebody else or something, and now he's regretting that decision. But he also had this 1080, which he's going to use in a build, but he told me I could use it for this testing and ship it back to him, so I'm very grateful to him for that. But here is the card. This is monstrous. If you don't actually build gaming PCs, or if you're used to working on laptops or things, this is a very big card, and it's very heavy too. As a size comparison, here's that M.2 video card, and here's the 1080 from MSI. Now, these come in a few different shapes and sizes, but this is MSI's version of the 1080, not the Ti or anything like that. And another card that I had tested was the one with the by one PCI Express slot right here. This is the 710, GT710 from Zotac. You can actually buy these things new, and it's one of the few video cards you can actually find in stock anywhere these days. But yeah, this is the 1080. We're going to see if we can get it working on the Pi. Now, there's a few physical constraints we have, and let me see if I can get the desk cam working. There we go. Yeah, I just had to reboot the Pi up here. You can see up here is a Raspberry Pi webcam. It's running off a Pi Zero, and this is actually running like the first version I ever set up of it. So you can find a video on my YouTube channel that I might link to later after this thing's over to set that up if you want to use one. But it's not the best quality in the world, but it's good quality, good enough. And I just wanted to have a camera to show you things over here. So here's this giant graphics card, and even has a fancy, look at this, a fancy protector for the PCI Express slot. Won't be needing that though. So the first problem we have, and let me move my microphone so you can hear me better. The first problem that we have is on the I/O board, it only has a by one slot. So there's a couple different things you could do. I could cut this little edge of this slot right here. And that way you could fit a card with all these pins into that slot. However, this card is, I don't know, 4 pounds, 5 pounds, it's massive. So it would just kind of fall out of the board. So another thing you can do is use an adapter like this. Now, there's some issues with this still, and we're going to see if this works today or if I need to do something else. But this is basically by one to by 16. And a by 16 card or by 8 card or by 4 or whatever size will work in a by 1 slot. It'll just limit the bandwidth. At least that's how the spec is supposed to work. Every once in a while there's a card like, you know, network controllers and things like that that won't work. But this is supposed to work. So actually, before I do this, I'm going to go and take a quick picture and I'll show you why. Let me go to my screen share. Oh, goodness. Yikes. Let's move OBS to another monitor here. There we go. So I'm testing all these video cards because I'm trying to build up a database of all the different cards that you can use on a Raspberry Pi. Because the Raspberry Pi is a very flexible computing platform that I use for tons of different projects around my house, and a lot of places use them in places of business or in products and things like that. And being able to use PCI Express cards allows you to do some really cool things with the Pi that weren't possible before this current generation of Compute Module 4. So for each of these devices, on GitHub, I open an issue and I want to make sure that I document the full experience. So throughout this video, I'll be copying and pasting things over to this issue. And the first thing that I do with every card is take a quick picture. So I'm gonna, what's that?
The live stream chapters.
Live stream chapters. Oh, okay. Yeah. I'm terrible about remembering to do any of these things. So this should switch to unboxing. Let's see if it actually does. Okay, yeah. Sorry about that. Live streaming is a lot harder than you'd think if you're trying to do more than one thing at the same time. So I'm going to go take a picture of it over at my little picture taking station. So it'll be a little quieter over there because I don't have my wireless microphone set up. So I'll switch to the other camera so you can at least see me do that, but it'll be really quick. Hold on. Let's see. Excuse me. And this is my sister who's helping me on these live streams.
Hello.
I've seen her very briefly there. Where's the camera? Back to here, and so I got the picture. I'm going to stick it on my computer, and I just realized my other camera is plugged in where I plug in my card reader. Do this, and I'll go to screen, and let's bring up iPhoto, import. All right, here we are. And I'll touch it up just a tiny bit. And I'll export it so I can put it on that site. Oh, come on, iPhoto. It's photos now, it's not iPhoto, but whatever. All right, I'll put this picture up there. And I think I forgot to advance the step. So there, take picture. Update that. All right, so we have a picture of it. That's the first step. That's the easiest part because I don't have to plug it in and I have no possibility of the magic smoke escaping on it yet because I haven't plugged in power. But the next two things are going to be trying to get power to it and connecting it to the Pi. So let me switch back. Let me switch back my camera over here. And it should come up briefly. Let's see. Hold on. No, it's still booting. The Pi has to boot itself up to be able to use the camera. All right, let's see if it's up. There it is. Okay. So I'm going to plug this in to the PCI Express by 16 adapter here. And at this point, it shouldn't get enough power. I'm going to boot it up and see what happens. I don't think it should get enough power to actually run or do anything. So I'm going to plug the Pi into my 5-volt or 12-volt 5-amp adapter and see what happens here. I see there's LEDs. The fans aren't spinning. I don't think the fans do spin on this one until it gets up to 60 degrees Celsius or something. It has like the silent mode or something. What's up? Oh, switch. Oh, I need to switch this. Okay. It's good to have somebody to help you with live streams. How am I doing? I'm doing good. Thanks, 737 Factor. Does Jeff own an M1 ARM Mac too? No, I don't yet. I'm hoping to get one. I'm kind of waiting till the M2 comes out or whatever's next, just because I'm hoping that that the that the next generation will have like 32 gigs of RAM and better specs and things. Okay, so I'm going to switch to my screen and try logging into the Pi and see what it sees right now. SSH Pi, I think it's 10.0.100.119. So, whoops, oh my goodness. Okay, so we're logged in, lspci. Yeah, it's not seeing it. I can see lights on the card, so let me switch over here. I can see that there's some LEDs and there's a light on top, so it's getting some power, but I think the card to power up completely needs all the rest of the power. Did someone else post a super chat? What was that? Walter. Oh, here we go. Over 600 watching. Yeah, go ahead and hit the like button. YouTube Analytics is always telling me I need to increase this or that or whatever. I don't care too much about it because I just am trying to have some fun with this YouTube channel.
You're just out here vibing.
Yeah, my sister says I'm vibing. She's a few years younger than me, so she uses these terms that I don't quite understand. But yeah, but she's very helpful with these live streams. So okay, so I'm gonna need more power for this. I'm gonna shut down the Pi. Shut down now. Okay, and that's off. So I'm going to need more power for it, and I'm going to use, goodness, I'm going to use this Redragon RGPS 700 watt PSU. Now I looked up the specs for this 1080 card, and it said that it was supposed to get up to like 200 watts or 210 watts. I don't know, some crazy amount. I'm sitting here with my Raspberry Pis thinking like 60 watts or 40 watts is a huge amount, and then this one card is using 200 plus watts. And I saw that there's some cards that use 2 8-pin connectors and can consume like 300 watts. That's kind of insane. So anyway, I have this 700 watt PSU, and it's fully modular. The reason I bought that is just because I hate having wires all over my desk when I'm doing these projects. But this presents us with some other problems because you can't have, a power supply won't turn itself on unless it's actually in a PC, because normal PCs have like a power switch through the motherboard that shorts a connection that turns it on. So I'm going to show you how I work around that issue. First, I'll go ahead and plug this in. All right, and am I on the right thing? Yeah, we're not yet to the trying to get it recognized phase. So I'm going to switch to my desk cam so you can see the setup. I'll move the mic again. So I have some power connectors here. First of all, I'm going to connect the Pi to the power supply. So another thing I've found out is it's not a great idea to power different devices on the same computer from different power supplies. So I just used this barrel plug. It goes into the 12 volt here. And they're both plugged into the same UPS. So, you know, the power from the wall is pretty much the same. It's not like I'm getting two different circuits in my house. But this is a different power supply, there could be minor differences in the way the power comes in to the Pi's 12 volt supply here versus what's coming to the card's other power supplies through this power supply. So you can actually power the Pi through a floppy connector. This is a 4-pin floppy connector here. And I have an adapter. It goes from Molex to floppy. And another thing that, this might be more superstition, but in some ways it's also makes sense. Like the farther away from the plug on the power supply you get, the more chance that there could be a flaky connection or could be more power drop, especially if you have a really long cable. This one's not long enough really for that. But I'm going to power the Pi through the power supply like this. These connectors are terrible. Bought these all from third parties on Amazon, so you never know what you're going to get. But I have used it before and it worked, so that's good. So I'm going to power this through the power supply, plug it into its rail up here. And I actually took apart a 600 watt version of this power supply after I fried it. And these power rails are all kind of connected together. So it's not the most complicated power supply in the world, but it is good to use separate cables for things, for cable management and for the fact that you can use the closest plug to the power supply. Now this guy is going to go into one of the 8-port connectors up here. And I hope this is right. Like I said, I don't build PCs for a living or anything. I'm not Linus Tech Tips, or Gamers Nexus or any of those kind of things. But I know I need on this card to go into 8-pin. Yeah, this thing's huge. 8-pin up here and 6-pin here. So this has like a split power connector. 6-pin there. So I have those two in. And now at this point, I think I might have solved the power issue. We'll see. So I have the Pi plugged in there and this plugged in here. Now on the power supply, I have it plugged in, and if I turn it on, nothing happens. Like I said, these power supplies have an internal little switch that won't turn on unless there's a power on pin shorted in here. So I made this little guy. And there are commercial versions of this too. I actually destroyed another power supply when I was testing this because I had other wires coming out and 2 of them shorted, and then it shorted something internally and made the magic smoke come out. But I made this little guy which jumps the PS on to ground, basically saying like the motherboard is switched on. So when I plug this in, this should turn on the power supply, this should turn on the GPU and the Pi. Another weird issue with a lot of PSUs is when you have them powered up but don't have any power, any load on the motherboard connector, after a while something internally is like, yeah, there's not load and that's not great for this power supply, so it shuts it off. And I think part of that too is a lot of the projects that I do on the Pi only use like 20 or 30 watts total. And this is a 700 watt PSU, and it's not great to run a heavy PSU like this for a tiny load. It's not efficient, and it also can cause damage over time. So these things for safety will shut themselves off if there's not enough load. So anyway, I'm going to, yeah, someone says, why don't I have a switch? I'm just lazy. That's really the only reason. So here, I'm going to try this. Let's see what happens. If I can actually line it up. There we go. Okay, so fan spinning is a good thing. It's always fun when I accidentally get one of these power connectors in the little Noctua fan over here that's cooling the Pi, because it makes fun noises.
How much power does the Pi itself need?
The Pi itself needs up to 15 watts-ish. This is a 12-volt power supply on the I/O board, but you can actually power it OTG on a lot of devices. Like I have this this Pi Tray Mini from SourceKit. It can power it through USB, and there's the Pi Anoras coming in the mail. There's a lot of things, and you can power it over PoE. I actually am going to test some PoE Plus and PoE++ adapters from a couple different people soon. Subscribe so you don't miss that fun thing. So it looks like everything powered on. There's no smoke yet, and the PSU is not turning off. So I think we're good so far. I'm going to switch over to the screen, and we're going to see what happens here. Let's see. Okay, so I'm on the screen, right? You can see my screen, I hope.
Yep.
Okay, good. So I'm going to switch to the next mode, which is lspci. We're going to see, whoops, oh my goodness, I hit enter on the wrong screen. I'm glad I didn't stop the actual chat. Thank you, Tomas, for the little thumbs up pair, I guess. Very fun. All right, so we're logged in, lspci. Hey, there it is. Okay, so the next thing that I normally do on these, and for some reason I closed my window, so hold on. I'm gonna go back to the site where I'm doing the debugging. And this is another thing that I tell people a lot of times, like people are like, how do you do all these things so frequently and manage all this stuff? The reason I can do all this work and work on the YouTube channel and all these things and work on open source is I document everything I do. as I'm doing it so that I always have a reference and can always go back and do it again. That's some good advice for anybody getting started in computer science or anything like that. Always document everything. Some people just have a list in their favorite text editor and they just use the list. Like I do these little text files all day. Other people use GitHub or GitLab or a private instance of something. Whatever works, just always document everything. And it's just a huge help. And since I can do it all open source, I can document it in the open. All right, so let's see. I'm going to say sudo lspci-vvvv, and I'm going to get all of this information because sometimes you need to go back and reference this information about the card. So I'm going to grab this, and I'm going to put in here lspci-vvv gives. And then I'm going to also put a note, had to power the card through an external 700 watt PSU. So I could put power through the 8-pin and 6-pin connectors. And it's not only for me, but anyone else who searches on Google for how to do this stuff, even if they're not looking for how to get this card working on a Raspberry Pi, somebody might need to do something. Maybe somebody's working on the Nouveau Driver or something, and they need to find some information. This is nice to have on the internet for other people to see. So that's why I often put these kind of things in GitHub issues or on blog posts and things like that. Jeff is a robot while writing documentation. Yes, Eric. And by the way, that is the Eric who is the one who lent me this card for today's testing. So thanks very much for that. Yeah, so it's there. Now, the next thing I'm going to check is the bar space. In my previous video on video cards on the Pi, where I talked about this little M.2 card and some other cards, I mentioned that the Raspberry Pi Foundation actually they actually increased the bar space on the Pi, the default, from I think it was 64 megabytes, which was way too low for a lot of things. That was a problem I was running into so frequently. They switched it from 64 megabytes to 1 gigabyte by default, which helps with so much. Like almost all the cards I try now work out of the box, no bar space allocation problems. And I thought that was funny. I poked fun at the Linus Tech Tips channel and Linus Media Group in one of my videos, and there were like probably 50 or 60 comments who didn't see the sarcasm there. I think I said something like this little unknown tech channel called Linus Tech Tips. Apparently people don't understand sarcasm. I mean, it is the internet, but I had so many comments that were like, your channel is so small and his channel is so big. It's like, okay, people, that was sarcasm. Anyways, the point was that in one of his videos, he said that the reason that GPUs don't work on the Pi is because it only has 256 megabytes of bar space. And that's not true. So anyway, maybe they'll post a retraction sometime. So anyway, if I need to, I can give myself more bar space using this guide that I wrote. Again, I did this like 6 months ago. If I had to do this, if I did it every day, I'd remember how to do it by memory, but I do this like once every few months now. And so that's why I wrote this guide, and it helps me, it helps other people who need to do this. And yeah, that's why I do everything out in the open and take notes on everything I do, because otherwise I couldn't replicate what I do. All right, so we're gonna say dmessage, and this is gonna give me the kernel's output of what's happening. And I wanna go up to the PCI Express bus interface. All right, so here is all the PCI. And I could also do dmessage grep PCI like that and just grab that, but I like to see everything because sometimes there's something else weird in here that you see where you're like, oh, I didn't realize that happened. So I'm gonna grab all this. Here's the PCI initialization and go over here and paste that in too. Dmessage shows. All right, so the most relevant part here is these assignments, the bar space assignments. So everything else is here. Just saying, like here it's saying that there's a 5 giga, I forget what this is, giga transactions per second or something, basically gigabits-ish, but speeds on PCI buses are weird things with full duplex and all the different things involved. In the real world, you can only really get 3.4 gigabits of data through a PCI bus by one on the Raspberry Pi Gen 2. But anyway, this is just saying like it's negotiating. It saw something on the bus. It's trying to load it. It's getting it. And then it sees that there's 4 gigabits per second of bandwidth limited by one link. And you can see where the Pi leaves some performance on the table. It's capable, this card is capable of 126 gigabits per second with a by 8 or a by 16 link. But it sees that it's on a Pi with a very small by 1 link, so it's going to limit it to 4. So what is that? 126 divided by 4. We're leaving about 30 times bandwidth drop by using this on the Pi. However, I mean that a thing like this will not need all that bandwidth if you're doing it for compute, AI, and things like that. But down here is the assignments. These all are working, so that's cool. This used to be a big issue before that patch landed in the kernel. And it does say that it failed to assign this here. This is I/O bar space, and this is something that typically does not matter. This is for older PCI stuff that is used on older architectures and things. The drivers typically don't care if this is missing, so that shouldn't be an issue. But if I scroll down, if you're on a Linux workstation, an x86 computer with an Intel or AMD chip, later on here, for most of the defaults, you'd also see it initialize the video card somewhere down here. So you can see it's actually initializing the VC4 GPU. That's the one that's built into the Pi itself. But there's nothing down here. That's the end of it. There's nothing down here initializing Nvidia. So we need to install a driver, and I'm going to switch. Excuse me. I'm going to switch the Nvidia Driver section here. And we're going to try installing NVIDIA's actual driver, which I need to find. NVIDIA ARM64 driver. Here, nvidia.com, download. This is, well, I want GeForce. Let's see. What is this? The RTX 30, no, not a 3090. It's a GTX. What is this one? It's a GeForce GTX 1080, right? GTX 10. I don't know. I don't see it in here.
Are you asking us?
Yeah. 10 series. Okay.
Hey,
GeForce 10 series. Okay.
Way to remember to change the chapter title.
Yeah.
I meant to say that.
All right. ARch. See, so NVIDIA has these drivers, but I always wonder, like, what systems are they actually validating them on? I'd love to know that, because I would imagine they work on something. And, well, yeah, US, that's fine. Search. Okay. So here's the latest driver, 460.80. Looks like it was released about a month ago, 107 megabytes. So I'm going to download it to my Mac and copy it over. This is another thing I hate about proprietary drivers and things. Actually, it looks like I can copy this link. Let's see if I can copy that link and download it straight to the Pi. wget. Oh, never mind. Okay, so they do give you a direct link. I thought at some point NVIDIA didn't give direct links to the file itself from their servers, but it's nice that they actually do. But it's not nice that it's a proprietary driver. I wish that they would make it open source, because if this doesn't work, there's nothing I can do to make it work. I might be able to help them debug it a little bit, but I couldn't make it work on my own. They'd have to send me a new driver version over. So next thing I'm going to do is chmodit +x NVIDIA, so I can run it. And if I do this, sudo./NVIDIA, I'm going to run this. I don't think it'll work yet because I need to install the kernel headers for it to compile, but we'll see what it does. Wait, 511. Oh, 2 days ago. So this driver's only 2 days old. It's so new. Hopefully there's some driver engineer inside of NVIDIA whose mission in life is to get this working on the Pi, and he just uploaded a new version just for the stream, but I don't think that's true. Eric is saying that he had a 3090 on by 4 mode. Oh, well, that's annoying. Hopefully that's not the case with their driver. All right, so that failed, and give me back. Okay. Thank you for giving me back my prompt. Sudo apt install, right, I think it's Raspberry Pi kernel headers. All right, and I'm also gonna, again, I'm gonna document the things I'm doing here. So, driver install attempt number 1. Downloaded, what is this? 460.80 driver from Nvidia's website. Next up, I tried, and then I installed Raspberry Pi kernel headers. Okay, what's the next step here? I'll try this again. Let's see what happens. And Eric, if you don't have to keep paying me money to say things to me. I mean, I'm not going to argue too much, I guess. But if Eric says something and I don't respond to it, then other people in chat can just reference it and mention it to me until I respond to it. Yeah, Katie is good at. She has a much better laugh than I do.
Thanks.
You're welcome.
I think your laugh is fabulous.
Oh no, did I make a typo in my own thing? .80. Goodness gracious. Okay. Ran the driver.
Eric said he's going to send us Slack.
Well, I don't have Slack open right now, so, but I can actually open it on my phone. You know what? I'll do that. Let's see, Slack. There it is. Hopefully Eric is not skipping any important meeting for this. Okay, I have Slack open on my phone, so if Eric sends me a message, I can see it. I might see it. Man, this is taking forever. Let's see. I mean, it is compiling on the micro SD card, which is not known for blazing speeds. Building kernel modules. Yeah, so another thing is, again, I'm going to plug the subscription. Subscribe to the channel because tomorrow I'm going to be talking about heavy things. I'm going to be talking about this guy again. I actually have, this is one of the coolest new drives that I've tested. This is an NVMe SSD with the U.3 standard. I'm going to be talking about that tomorrow in a video, so subscribe so you don't miss out on that. The sad thing is that this enclosure, these hard drives, these are Kingston like 240 gig SATA drives. These things, I bought them for like 25 bucks or something. They're probably worth like 60 bucks now because Chia miners are now making hard drives hard to get too.
Super chat.
Oh, there's a super chat.
With a smiley face.
Will I be making more Kubernetes videos? Probably. I haven't had time lately. I'm focused on some of these Compute Module 4 things. But probably sometime later this summer I will be, because I'm working on finishing up my Kubernetes 101 book. What is this? Oh, you know what? I don't have X Windows installed. Well, we'll see what happens. I don't have a GUI installed, a GUI. I have, this is Raspberry Pi OS 64-bit Lite, so I might need to try this again later. I don't have an X configuration file, so I'll say no to that. Installation is complete. Okay, now I'm going to shut it down. And the cool thing is the PSU has not died on me yet, so that's a good thing. I shouldn't have shut it down because I forget what pins I need to short on the Pi to boot it back up. So I'll need to unplug and replug this guy to tell the Pi to power back on. Okay. And I'm actually going to switch my input. So I'm going to get off of the, let's see what the Pi is doing. Okay, the Pi is booting. It doesn't look like it's loading any Nvidia stuff though. I might have to install X Windows or something. Let's see. Go back to my other thing and we'll log in here. So the card is still showing up. dmessage Nvidia. Okay, so here, let's see. Enabling device loading. It initialized. So, well, let me plug in. I didn't expect this to work, and I still don't think it's going to work, but let me plug in my HDMI to this card, which has, oh my gosh, there's like 100 ports on here. Oh, that's not HDMI, that's DisplayPort. Let's go to HDMI. And let's see what this thing's doing. If this works. Okay, switch my monitor. DVI. Am I getting any output? No, it just switched back. All right, so let me try rebooting the Pi and see if I get console output on here. DVI. So it's booting. No. Silly thing. How do I not? Oh, I need to turn off auto switch. It's off. Okay, DVI. So I'm not getting any console output. The screen is blank. No input signal, it says. So that's not working. Let's see. Let me switch back here.
There's some suggestions in the chat.
Nvidia SMI.
And above that.
Here we go. Segmentation. Okay. Oh, I didn't see that in the, let's see, dmessage. Oh, here we go. So Nvidia was trying to initialize. Here we are. All right. So this is the same issue I was seeing with I think with the GT710. So we are getting the same problem here. And again, this is, I mean, it's good information to have, but it's not going to help me because I don't have the source code, so I can't do anything with this. So I'm going to put this in here. Nvidia Driver resulted in the following output. And thanks to, oh shoot, everything's going away in my chat. Thanks to, who was it that first said Nvidia SMI? I'm going to give some kudos here. Robert Bear, I think, was the first one to, no, Ken Howie? Oh, sorry. Oh, there's someone else. Man, everybody was saying the same thing up here. Apparently everybody knows everything about Nvidia in this chat, so that's cool. I wish I could send this card to somebody else who knows more than I do. So Alex and a bunch of other people for suggesting Nvidia SMI to get that debug output. I mean, it's in dmessage too, but Nvidia SMI was helpful for that. Let me go back to my live stream. And Eric, is somebody saying check Slack. The issue could be that it's running on by one mode. Yeah, I mean, there's a lot of things that could be issues here. One of the other issues is the hardware. So I hope I'm still, yeah. So let me switch to my desk cam. The hardware, actually let me switch to the Sony cam, sorry. Let me get my face out of here so the Sony AF doesn't look at my face. This little chip, this BCM 2711, I think it is, the PCI bus inside of it, the actual hardware, is set up slightly differently than spec. There's some weird issues, and especially with 64-bit versus 32-bit, some things just aren't implemented the same way. Because this chip, the silicon inside, silicone, I don't know how to say that. Anyway, the actual wafer inside was built for like TV set-top boxes. It wasn't built to be a general purpose computer. So, you know, everything we're doing here is a little crazy. But it looks like this driver's not going to work. So surprise, surprise, that's what I expected. We're going to have to recompile the kernel. That sounds super cool and stuff, but for somebody who does this on a daily basis, and I have a t-shirt for this on my store, by the way. My sister's wearing, so let me switch to the room cam. My sister is wearing the "It has been 0 days since I recompiled the Linux kernel" shirt. You can find that on redshirtjeff.com. For people who recompile the kernel a lot, it seems like, oh yeah, you recompile the kernel a lot. For somebody who's never done it before, which was me last year, you're like, oh my gosh, that's like voodoo magic. I don't know how to do that, blah, blah, blah. So, you know, some people will be like, oh, this is amazing. And other people will be like, oh my gosh, this guy doesn't know what he's doing. Why isn't he using Ccache? Why isn't he using distcc? Anyway, so I'm going to recompile the kernel and put in Nouveau. And I'm actually going to shut down now. I'm going to shut down the Pi. I'm going to flash a new version of PiOS just because uninstalling drivers is never perfectly clean. So I'm going to do that. I'm going to unplug this camera. Sorry for that. So I can reflash it. And the Pi Imager is really cool now. One thing that I really like about it, Imager. The Pi Imager now lets you inject your SSH key, set up Wi-Fi passwords and things, all like that. And here, I think it's like Option C. No, Control Option C, Command Option C. I don't remember what the keyboard shortcut is for this, but there's this keyboard shortcut which is not exposed anywhere else. So it's not the coolest thing in the world because it's not very user-friendly to be able to do this. But you can now inject things like that, kind of like Cloud Init using the Imager, which is helpful. So I'm going to grab the 64-bit ARM64 Lite distro, open, choose this card, write it. Oh, here. So here's the customization settings. So you can edit the settings there. Yes. Hopefully you can't see my keyboard, so you didn't see my password. And it's going to write that. While it's doing that, I'm going to start recompiling the kernel. So I have on this project, this PyPCI Express GitHub project. Somebody commented on that GitHub post, so I'll do that while it's recompiling. Let's see, CD, Raspberry Pi, PCI, devices, extras, cross-compile. I have a guide and a Vagrant profile here for doing this. This is on a Mac, but you know, you could adapt things for a Windows PC or something else. This just makes it easier for me to have a reproducible build environment for compiling the kernel. Just because on the Mac there's some weird things you have to do, especially if you're on an Intel Mac. That's one thing that would be cool. If I had an M1 Mac, this might be faster. But I'm going to bring up this environment with Vagrant. And this basically runs an Ubuntu VM, and inside that VM I do the cross-compile because it has all the tools I need for it. And I could do this in Docker too. It might be slightly faster, slightly slower, I don't know. But the reason I did it here is because I can also use USB with VirtualBox on the Mac easily and connect it, so I could put a flash drive on it or a PC drive to copy the kernel over, that kind of thing. Let's see. Okay, so it's up, Vagrant SSH, not but SSH to log in. And I'm going to go in here. I actually already cloned the Linux. This is the Raspberry Pi Linux kernel. So this is a fork of the kernel that the Raspberry Pi Foundation maintains, or Raspberry Pi Trading. So I'm going to go in here and I'm going to make the config. So just a quick overview of how you compile the kernel. Raspberry Pi Linux. So this is the kernel source that builds a Linux kernel, and this is a fork of the actual Linux kernel, and the Raspberry Pi Foundation basically maintains this fork with their customizations for the Raspberry Pi, and they build the image off of this.
Move the chapter.
Oh, move the chapter. Yeah, let's go forward, because that's what we're doing now. And so what you do is you clone the source to your Raspberry Pi or another computer or something, and then you can build the kernel. The first step is to build a config file to tell the compiler what to build into the kernel. And the Raspberry Pi Foundation maintains one for BCM 2711. That's the chip, and the CM4 and the Pi 4. So different Pi models need different configurations. So there's different configurations defined. I think that's under ARM64 in my case, because I'm using the 64-bit. And I don't remember configs. I think it's in configs here. Yeah, so this is the one that's going to use. This is for RPi 3. There's different branches with older Pi models, I guess. or I think, yeah, the 64-bit kernel only builds on Pi 3, 3B+, and the 4 and CM4. So you can't build ARM64 on the older Pis because they're not 64-bit processors. So I'm going to do that. It's going to define the configuration, a .config file. So if I say cat.config, these are the default configurations you'd get with PiOS out of the box. So what I'm going to do is I'm going to run menu config, which is a little graphic interface, well, terminal graphic interface, that is, that lets me pick more options for the kernel, change options. You can do this just editing that .config file by hand, but you have to know exactly what you're doing there, and you can accidentally mess things up. So I'm going to go to device drivers. Let's see, graphics cards, somewhere in here. Where are they? My computer is really slowing down at this point. Graphics support, here we are. Nouveau cards for Nvidia. And Nouveau is it's like a what is it called? When you work backwards from something, backport type thing, or reverse engineering. It's a reverse engineered driver for Nvidia cards in the open source Linux kernel, because Nvidia doesn't provide any open source drivers. So they don't work as well for some things, but they do work somewhat for most things. So we'll see if anything helps here. The cool thing about it, so I'm going to save this, and that writes to the .config file, and then I'm going to go ahead and compile the kernel. So exit, exit, exit. Okay. So I'm going to go ahead and start that compile. And on my Mac, it takes up to 10 minutes, but I actually did a compile, so it has a cache of some things, so it should be a little faster. Let's see how this is doing. That's finished. So I'm going to boot the Pi itself.
There are some suggestions in the chat too.
Oh.
You can scroll through at some point.
Yeah. I won't be able to try everything today, just because I don't have all the time in the world. All right, so the Pi is booting off of its new 64-bit PiOS. And while it's compiling this, I'm also going to log back into the Pi. Once it boots up, it's still booting. Oh, and I can plug in the desk cam again so you can actually see it. I have all kinds of Pis booting up right now. Let me switch to OBS so I can see. Is it working? The fans are spinning. Whether or not you classify that as working, that's up to you. All right. Let's see, anything else fun in the chat? Yeah, don't spam. Spamming's no fun. No, this card should be working. I don't have any reason to suspect the card is bad. It's doing the same things that all the other cards have done that I've tried so far. So, 68 degrees CPU temp, and the Mac right now is doing, it's cross-compiling using all 8 cores. OBS, even though it says 10.5%, OBS for some reason uses like a lot more GPU and things like that in the background. So it is doing a lot right now. But the fans, ever since I started the stream, the fans have been going insane. That's why I want to get an M1 Mac at some point.
We're listening to it do its very, very best.
Yeah, yeah. I mean, the 16-inch MacBook Pro is the best Apple Intel era laptop, except for that stupid touch bar. But everything else is good about it. But that's not to say it's great. The thermals on it are terrible. Sometimes upstairs, if I have it in a cabinet, that I have a fan in the cabinet, but it doesn't push enough air. So sometimes the fans just kick on full blast, and I see kernel tasks go to 100%, and I know it's doing its thermal throttling, and I'm just like watching YouTube or something like that. And a lot of people, another thing, a lot of people are like, oh, you should just install Windows on Pi. And the problem is that the problem with these drivers not working is not that it's like Linux versus Windows. The Linux drivers do work for these cards. I know that because other people have these cards and have them working even on some advanced, like there's $500 to $1,000 ARM development boards. People have these things working on them. the problem is the Pi's actual PCI bus and the drivers for that in the OS. So I'm pretty sure, unless someone wants to prove me otherwise, I'm pretty sure nobody at Microsoft working on Windows is building PCI Express drivers into Windows for the Raspberry Pi. If that's false, please let me know. But I don't think that the actual that Windows on Pi is going to solve any problems here. Just make more because it's such a bloated, horrible operating system. Anyways, let's see. I'm not going to get too deep into that. I'm going to say sudo apt-get update. Not install. Upgrade-y. So I'm going to make sure everything's running on the latest firmware, latest OS and everything while it's compiling. Man, there's a lot that it's doing. There's probably a way to limit what it's doing so you only support certain architectures, certain versions of Nvidia boards. But yeah, my poor Mac is trying to do two things at once, and it's not a great situation. It's not the drivers. It's not the drivers that are the issue here for Windows on Pi. It's the PCI bus and the way that it works on ARM64 on the Raspberry Pi. So yeah, another thing, while this is compiling, I should mention, I have too many windows open. I should mention that for which card is it? Let me just go over to the actual site here. 5450. So the user CoreForge on GitHub has a 6450, which is very similar in architecture to my old 5450, which is similar in size to this Zotac card. And you can actually buy them. They're only like $70, unlike the $1,000 unobtainium GPUs, the latest generation ones. But CoreForge has gotten it working, and there's actually a couple AMD engineers who have given some input in this thread. So if you want to follow, if you can go that deep and you want to follow along there, you should subscribe to this issue, test the GPU on the Radeon 5450. I'll post that in chat here. So this issue could be fun to follow because CoreForge has gotten further along, and there are now a few engineers who are helping with the debug process. Come on, GitHub. Don't slow down the computer too much here. I'm trying to show the picture here. Oh, so this was his first success. He got the screen to actually output something, but it was a bit distorted. He got a little bit of the screen to show up. So I'd count that today. If I could get that, I would count that as a huge victory, but I don't think we're going to get that far. I mentioned in the chat before this thing, I give us maybe a 5% chance at success. And earlier I had a 10% chance of something going up in smoke. Luckily that hasn't happened, and the PSU has been happy. I'm guessing if you load it up with enough power like this video card is using, the PSU is a little happier. But yeah. So anyway, he got that, and then the latest was that he actually got the full output with a purple line on the side. So, you know, that's something. You're getting video from the kernel through the card into a monitor. I haven't been able to do that on any of the cards I'm working with yet. But we're starting to get into the weeds here. And part of the problem, if you read through all this, is that you find out there's memory access issues with the way the Pi system on a chip handles the PCI Express memory into the actual system memory, the mappings through that bar allocation. So I'm guessing that we're going to need to modify some drivers to work on the Pi, and it might be a case where there's like, here's a patch to get this working once we get it working. And even then, it's going to be like Nouveau, where it might not make everything work. Like you might not get CUDA cores to work on Nvidia cards, so you might not be able to do machine learning. I don't know. But I'm just trying to find this out and see what we can do, because it's fun. It's exciting, interesting. But let me look while this is still compiling. My goodness. I'm going to look. Somebody posted something here. Can I get access to the source code on the official driver, though? Or, to get that, you can disable. Oh goodness. See, this is the kind of thing that I might do, but probably not on the live stream, because I know that I'll mess things up 17 times, and you don't want to sit there. I mean, some people do want to sit there and watch me mess up 17 times, but most people would check out after the 14th time. That is basically life doing software development, though. You fail about 40 or 50 times and then have a success, and then the success is actually partly a failure, and you try it again 100 times. But I might do some of these things, just not on the live stream. So Virus also asks about ARch64. I'm running the 64-bit PiOS beta because the 32-bit is dead to me. It's for older hardware or hardware with very little RAM. But yeah, Moldy to Zoo Alex says, yeah, basically I'm using the 64-bit version. Good luck, we're counting on your airplane. Oh, or if you're in an airplane, I hope you're not flying the airplane and texting, but if you're a passenger, that's good. Okay, so what's here? Keep this version, that's fine. This is still compiling. My goodness. Please just finish. Yeah. Oh, it finished. Okay. So it finished compiling. The next step is to get this rebuilt kernel over to the Pi. So do I need to advance my thing? Nouveau Driver, recompile the kernel. Well, I'm still in that stage, so I'll probably forget to advance the little status to the Nouveau Driver at the relevant time, but the next step is I'm going to copy this over, and before I can do that, okay, this is finished. So I'm going to say sudo nano, what is it? Deconfig, and I'm going to let myself log in with password and go down to the bottom and delete that. Actually, yeah, save that. Okay, and I need to reboot this so it's on the latest kernel version. Actually, I don't need to reboot it, but whatever. I just rebooted it, so we'll wait for it to come up again. I'm going to log into I'm going to mount the Pi's file system onto my little VM over here where I did the cross compile, just because that's fast enough for me. There's a bunch of different ways you can get the kernel into the Pi. The easiest way, if you're just starting out with this, the Raspberry Pi Foundation actually has a guide, Raspberry Pi kernel compile. And this is what I used to learn how to do it. This guide steps you through everything in detail. The reason I'm not doing it on the Pi is because it takes about 50 to 60 minutes on the Pi 4. So, you know, I didn't want to sit here for 60 minutes. It's a lot faster on my Mac, and then I can copy it over. And it has a guide for cross-compiling too. But I set up this cross-compile environment with this guide just because I'm doing it enough that it warrants having the guide. And at some point I should probably automate it so I can just click a button and go, but I don't have that yet. So let's see if it's rebooted. Okay. And then I'm going to copy it over. I'm going to see if this works. SSH root. Yes. Raspberry. Oh, I didn't set a password. Password. Raspberry. Nobody hopefully is, well, Katie's on my home network right now, so she could log into that Pi, but I don't think she will.
I'm a little busy.
She's busy. Okay, so I'm logged in, so that works.
Mark asked, can you not SCP from the VM to the Pi?
I can SCP too, but the problem is you also have to copy some things over to the boot volume, and when you're doing the modules install, it's nicer just to have the path mounted. So I'm going to do this here. I'm going to make an ext4 directory and a FAT32 directory for the boot volume, and then I'm going to mount these things. Okay, mounted that, and the cool thing here is if I ls/mount/pi FAT32 sudo, then I can see all the stuff that's in that directory on the Raspberry Pi through the file system on this thing. So I can now just run this command to install the kernel modules, like that. And then these commands to copy the kernel and the device tree files. This takes a minute. It's already as up to date as it needs to be, basically. I don't need any new firmware or anything like that. Good luck from Europe. Thank you. Thank you from St. Louis, Missouri, USA. You should also subscribe because I'm going to be giving my full review of the Starlink satellite internet service pretty soon. Probably in a week or two. I set up, and I've thought about doing a separate video for this. I've set up the Raspberry Pi internet monitoring service on it that I found from someone else, remixed it, and I have some other things on it. So I'm going to be doing a full video on that probably, as well as on Starlink itself, if you're interested in that kind of thing. If you're somebody who's watching this from a very rural internet connection that's slow and seeing it very pixelated. All right, so that's finished, and I need to copy over the kernel and DTBs, and then I will unmount. All right, so now the Pi has the new kernel, so I'm going to say sudo reboot, and it should come up with my new kernel, and I can check that. I should have run uname on it before, but I can check that by running uname and checking what kernel is being used. Have I gotten any VGA out or anything? No, I even tried. So this little card here, you can't really see it that well because it's tiny here. Let's do this. I'll move my face out of the way. This little card here is the I always say ASRock M2 VGA. This little chip has 16 megs of VRAM. It's such a tiny little thing. You'd think that a chip like this would be easy to get working on the Pi because it's so simple, and it might be if you write a custom driver. There's even a Linux kernel experimental driver for it, but it didn't work, and it seemed to have the same issues as all these other drivers. So I don't know. I haven't gotten anything to work with VGA or HDMI or anything. But like I said, CoreForge did get one thing to work. So let's see. Oh, you know what? So I didn't even have it up here. Let me switch my monitor over. I think we're locking up because Nouveau is locking up. So let me switch to desk. All right. So I can't tell. I don't have. Well, I can't see what you're seeing right now, except with a 15-second delay. So this little guy here, this little green light is on, I think because it's locked up. So I can check that by hard resetting it. So I'm going to unplug and plug back in. And we'll see what my monitor shows. Let me switch to the Sony. Oh, you know what? I don't have it plugged in through there, so let me switch this. Switch this over. Okay. Might need to reset again because I think it locked up already again. Let me try this again. Ah, come on. Okay, so I saw the rainbow screen on this screen down here, which you can't see. I should have found a way to have a camera on it, or this is an input, but I don't. So let's see. It's just black. And the problem is, so this is booting into an X window environment, but I think it basically just blows up at some point. And I can't even get the output from it. I might need to blacklist the driver. Yeah, and if I need to do that, can I? Oh shoot, I didn't do it. I should have blacklisted it earlier, but I didn't. Okay, so the Pi will not boot with the card plugged in. I'm going to unplug the card and try this again. All right, so unplug the card, boot the Pi. All right, so the Pi is booting this time. That's good. And I can't see anything in live chat or anything right now, so hopefully there's nothing crazy going on. Katie will flag me if there's anything interesting.
Everybody's great.
Good.
Lots of suggestions about custom CM4 boards. And,
yeah. There will be a few more videos coming out in the next week or two. I'll show you right now. This is cool stuff. Let's see.
you need it. You got it.
There goes all my SAS stuff. Okay. So I'll show you this. Because again, subscribe. There's a lot of cool stuff happening. I have the tiny router boards. I'm going to be taking a look at these, installing OpenWRT and maybe ViOS to test them out. I have this other router board, so we'll do a head-to-head comparison type thing. What do we got here? Oh, this I'm super excited about. This will be fun. This is the first, there's another one like it, but this is the first CM4 blade. Very cool. It's a blade. The CM4 goes, where's my pinky? Oh goodness, it's backwards, so I can't see anything. So right here, the CM4 goes there. Power over, oh, this is everything's backwards. Power over Ethernet, and it has an M.2 slot. Man, it's hard to do things backwards. M.2 slot, so you could fit up to 21 of these in a 1U rack mount unit with Raspberry Pis. Power them all over Power over Ethernet. It's all built into the board. It has an RTC. Very cool little server appliance thing. This is from Uptime Lab, so follow them on Instagram. I will be. Yeah, yeah. So Fallout there. Follow him on Instagram for his updates because he's further ahead than I am in this game. Someone else is making one too. I forget who theirs is called. But anyway, I'll be having these. There's a few other things in this box that I will not get into today. 2 things coming in the mail. A lot of fun stuff. It's exciting because people. Oh, there's a super chat. I don't see it. Okay, super chat. Oh, well, thank you, Mate. I'm guessing that's it, but I could be wrong. All right, so I'm going to log into the Pi. Oh, and I realized I was on screen, so that was very tiny. You probably could barely see those boards. But anyway, I'm going to log into the Pi. What is it?
Yeah, I am Jeff's sister.
Yes, Katie is my sister. You can, here, wave to the camera again. There's Katie.
Hello.
All right, so I'm going to touch blacklist nouveau.conf. Oh, sudo. Or I know every time in one of these live streams I do this, people are like, oh, you can just do this. I know that, and most people do. Don't worry about it. Sometimes I just want to go up and then sudo. All right, so nano blacklist nouveau. Sudo. Make me a sandwich. All right, blacklist nouveau. I think that's it, right? Yeah, okay. Sudo shutdown now. Oh, the power supply is doing its fun thing where it turns itself off. So I'm gonna try to make that not happen again. And I'm gonna boot this thing up. I need to plug the graphics card back in. Turn on the power supply. Give it power. Okay. Please don't shut itself off. This is the problem that would sometimes happen. And look, you can even see my terminal session got locked up because the Pi shut down ungracefully. So I blacklisted that driver. So what's going to happen is it shouldn't try initializing this card until I tell it to. Although, okay, yeah. It shouldn't try initializing the card until I tell it to. And then it should let me do that while I'm monitoring dmessage. And you can see what happens here, which is what's happening with all these cards. So I'm going to do dmessage -- follow in this window. So you can see this is the normal boot. It's not initializing any of the Nvidia stuff, or, well, Nouveau. The Nouveau Driver is the open source one, but it did initialize the VC4 GPU. Let's see, so it's following the log here. I'll make a little gap so you can see where it is. Following that log, I'm going to go into another session, and I'm going to say sudo mod probe nouveau. So this should load that kernel module, and it's going to try initializing the card, and we're going to see what happens. So here it goes, enabling device, Nvidia GP104, and at this point, I'm pretty sure the Pi is completely locked up. If I go over here, let's try SSHing into new. Yeah, SSH isn't connecting. If I control C here, that's not getting me out of there. And the Pi is unresponsive. And this is what happens at all these video cards do the same thing. So the next steps here, I'm not going to do this on the live stream because, like I said, it's 49 failures and you get maybe a mild success. That's a bit longer and more boring than most people would stick around for. So I'm not going to do that on the live stream. But if I ever do get some success, I will share it in a separate video. Switch chapter. Okay. Nouveau Driver. Yeah. Thanks, Katie, for being my brains that are actually thinking about the live stream. So yeah, like I said, I gave it a 5% chance of success. I actually had false hopes with that Nvidia driver, but we're always locking up here at different stages, and we're going to have to figure out the driver support for it. What I can do is enable more debugging in the kernel and find out exactly what code we're hitting, because if I look up this, yeah, now it's broken pipe. The connection is dead completely. So if I go in here and go to the Raspberry Pi /Linux and search for the string, it's probably somewhere in here. So Nouveau, I can find these strings. Whoops, darn it. I can find these strings and figure out what part of the driver they're coming from, figure out what the code is, put in some breakpoints, look at some stuff in there. That's how you do it. And then also another thing that some people do, which I've never done before, which would be kind of cool, is you can debug the actual PCI Express bus data going through the kernel and try to figure things out that way. Now that's a little more advanced. Like I said in my last video for the for the actual video cards, that's more advanced than I have the ability to do. So some of the other people in GitHub are able to work a little deeper on that. And that's my hope, is that somebody, especially an AMD or an Nvidia driver engineer, might be able to be like, oh, yeah, we can just change this and that. And a couple of the AMD engineers actually have been in, let's see, they've actually been in that issue for the, let's see, no, I didn't want to go there, for this 6450 card. And, maybe there's an Nvidia engineer out there who could sneakily help us out, or maybe Nvidia would throw a bone to the open source world. I know that the relationship there is not the most beautiful, but it'd be cool if that would happen, so that we could get a card like this working. Because there's a lot of people are like, oh, you can do mining and stuff, and mining ruins the world and all that. And that's true to a certain extent, but there are a lot of things that you can do with a graphics card on the Pi, or that you could do, I should say, because you can't do anything right now except for if your CoreForge get a console terminal loaded. Thanks for all the inspiration. You're welcome. But I wanted to do the live stream today because I had to do this work anyways with this card, and it's nice to at least have the work in the open so that people can see exactly how the whole debug process goes. And to that point, I should actually put this in here. I should put my debug output. So let me go to here. I'm going to stick that into the issue with Nouveau Driver compiled to a custom kernel build. I tried blacklisting and manually loading the Nouveau module, and dmessage showed this before total system lockup. So yeah, I mean, I can get a lot deeper than that, and I will at some point with this card before I send it back to Eric. It'd be really cool if we can get it working, but worst case, I go back to testing on my GT 710. But that will be a subject for some future video, maybe at some point. It would be, I actually have gotten the Halo Master Chief collection running through a Pi. Not very well, using, what is the Nvidia?
When was that?
No, what is Nvidia, or not Nvidia, Steam. What is the thing called? Steam Link or something?
Yeah.
Yeah, Steam Link can actually work. It was not a great experience, and the latency was terrible. But you can do that now. But it would be really cool if you could run something like that on the Pi. But that's also a Windows native thing, and that's a lot harder. Yeah, someone's talking about FPGAs and things. There's a lot of things I want to do, but there's also a lot of things that I have the time to do. And my list of things that I'm going to be working on is already pretty long. But a GPU working on a Pi, I mean, if you count the fans spinning as working, then yeah, I got this GPU working on the Pi. It also has LEDs. I mean, that's kind of fun. Like there's a light on the top. I don't know. Every time I see someone do a PC build and they're throwing all these RGB things everywhere, I'm like, oh my gosh, my eyes would explode looking at all of that.
But it's cool.
It's cool for a minute or two, and then you realize that the computer's going to be sitting on your desk for the rest of its life.
And then you turn your room lights off and you game while the computer's lights are all going.
I will never understand RGB, but nowadays the hard thing is some things only come with RGB, and you're like, what if I just want it to be like dark and black or whatever? I don't know.
Duct tape, I guess.
Yeah, duct tape. Actually, I do on the on this hard drive controller thing. It has down here. I could turn it on for you and blind you. This is like the world's brightest blue LED, and so I put electrical tape over it because nobody needs that.
Mark was wondering if you have any ideas for a custom CM4 board.
Well, so one thing that I really wanted to do was a CM4 NAS, and I should mention that this is the wire trusty SATA. Let me get my face out of there so Sony doesn't grab it. This is also a board. I was thinking about making basically this, and then someone else made it, and I'm like, okay, never mind. This is a SATA board with 4 SATA connectors. It'd be cool if someone would do like a tri-mode SATA, SAS SATA and NVMe board too. That'd be a lot more expensive, and it's way overkill for a Pi. But you can plug in 4 SATA drives directly into this board. It comes with a 3D cutout acrylic case. I'm going to be doing a video on this board, so I'm not going to spoil too much on it. But this is really cool. This is basically what I wanted to build for my NAS, and I just never had time to think about it too much. And then, like I said, someone else built it, and I'm like, okay, that's it. That's perfect. You just plug the hard drives right into there, and you have a NAS. Very cool. And another thing that I would modify is I might put 2.5 gig networking on there, because even though you don't get full throughput and bandwidth, you can get 2.5 gigs on the Pi. And for bursty workloads, not things like movie streaming, which don't even need a gigabit, you can get that full bandwidth. But anyway, so this is cool. The wire trusty SATA. It's already up on the Pi PCI website, which is linked in the description, so check that out. And like I said, subscribe. And if you want to see me keep doing these crazy things, I might never have enough money to afford a GeForce GTX 1080 like this. So thanks again to Eric for loaning me that. I could afford it, but justifying it is a different thing entirely. So anyway, if you want me to be able to do things like this, please consider supporting my channel on Patreon or GitHub sponsors. And thanks for watching today. I will be, as always, I'll be posting all my updates on GitHub. So if you want to follow along after this video, go check out GitHub. The project is linked in the description. And if you are an Nvidia engineer or an AMD engineer, please go and help us out. We'll see if we can get one of these cards working. I think it would be super cool. I know that some people like Team Red and Team Green or whatever. I'm not on any team, except I do like that AMD is more involved in open source and that they're spanking Intel on CPUs right now. But I think it would be cool if one of those two teams could push this over the line and they would get the bragging rights. So anyway, that's all I have today. Thanks for watching. We achieved all the goals on the stream. Let's see, what is it? Conclusion. So here's the conclusion. I will finish as I do all of my videos. Until next time, I'm Jeff Geerling.